Last time we introduced chapter 15 and we were talking about the collision. We have seen that we can have, if you want, central collision or oblique collision. So let us remember what we were doing here. Okay. So we were saying that in case of impact, we can have several cases. We can have the case of central impact. So as you can see in the figure here, the initial velocities are along the line joining the centers of the balls. And in this case, it will be much easier to solve because we know that the final directions will be along the same line, but what will change is the algebraic values of velocities. So we will just have in this case two unknowns, which are VA2, VB2. So we need in central impact, we just need two equations. And in general, what are these two equations? The first one will be the conservation of linear momentum when we consider the system of the two particles, because what happens in collisions, in general, when we have a collision, the dominant forces will be the collision forces. So any other external forces to the system of the two balls will be a non-impulsive force. This is why when you have an impact, you can directly say, if I take the system of the two balls A plus B, I can apply conservation of linear momentum on the system. This will give me the a first relation between VA2 and VB2, knowing the initial velocities, of course. Okay, so I still need another relation to close my system. The second relation is given by the restitution coefficient. So we said last time that in case of collision, we define a factor E. E is called the restitution coefficient. It's equal to the ratio of the restitution impulse over the deformation impulse. Okay, what do we mean by this? So in case you restitute a certain part of the energy, this means that you will not lose this part of energy. You can have three cases. You can have complete loss of energy. So when you have deformation, you will not have restitution of any part of this energy. In this way, the two particles will become one block, okay, and they will move at one velocity. This is called plastic collision. So it is the first critical case. The second extreme case is that you don't lose any energy. In this case, the restitution impulse will be equal to the deformation impulse. So your balls will go to, their shape will go back to the initial state. And of course, here we talk about microscale deformations. If you look at the system, you will not see it, okay, because it's a microscale deformation. In case of elastic collision, the deformation will not be permanent. So once you have separation between the balls, you don't have any deformations. They will go to their initial shape. And you have an intermediate case in between. It's not plastic and not elastic. So the restitution impulse will not be zero, but will be smaller than the deformation impulse. And this coefficient E will give you an additional equation relating your velocities, because E is calculated as follows, as we have seen last time. It is the ratio VB2 minus VA2 over VA1 minus VB1. Just keep in mind that all these velocities are the projections. So this is projections along line of impact. So projection along line of impact. Now, in case you have central impact, you don't have any problem because already the velocities are along the line of impact, so no need to do any projection. While in case you have oblique impact, then you should do the projection. Let us see how, for example. So if I take an oblique impact, this is an example of oblique impact. As you can see here, the line joining the centers of the two balls is this one. This is called the line of impact. Okay, and you have that the velocities, the initial velocities are not directed along this line. So you can see that we have VA1 and we have here VB1. So we will have four unknown to determine: VA2, VB2, theta 2, and phi 2. So we have 4 unknowns, which are the magnitudes and directions of the final velocities. In this case, we need 4 equations. What will be the 4 equations to write in this case? First, you have several scenarios, and you will see, depending on the problem, we will see several possibilities of questions. So one of the possibility is that they gave you the line of impact. So if they gave the line of impact, then the first 2 relation you can apply. One is conservation of linear momentum. So of course, the first thing to do is the conservation of linear momentum for the system. This equation is a vectorial relation, okay? The vectorial relation will always, in 2D, will give 2 relations. So conservation of linear momentum will give equations in Y and in X, okay? And in X. So you have 2 relations. By just writing the conservation of linear momentum, you can obtain 1 relation in X, 1 relation in Y. So these are 2 equations. We still need 2 other equations, okay? The second one, so if you want, this is, we can consider that this is 1 and 2 because it will give 2 equations. The third equation will be by giving the restitution coefficient. So 3 is to use the restitution coefficient E. And the restitution coefficient, we just should pay attention to use only the projection along the line of impact. So here you will use the X components, okay? The X components of your velocities. And finally, we still need a force relation. What will be, do you think, the force relation? Look, what do we mean when we say this is the line of impact? What can you conclude from this? How will be the force acting between the 2 balls?
Opposite to each other?
Yeah, it will be along which line? Along the line of impact. Yani, the force of during collision, okay? Of course, if we don't have friction between the balls, if the 2 balls are smooth, whenever I have contact between the balls, we have that the line of impact is the line joining the centers, okay? And this means that knowing the line of impact, I know the line of action of the force between the 2 balls. So I know F. So we have a force only along this direction. This means what? This means that along Y, we don't have any force between the 2 particles. So this means that because we don't have forces acting in Y, no impulsive forces acting in Y, then the Y velocities will not change. Yani Vy of A at state 1 will remain the same. So the force relation, if you want, you can write Vay at state 1 is equal to Vay at state 2. وإذا بدكم كمان إذا ما in case the conservation of linear momentum على السيستم عملتوها بس in X، ساعتها فيكم كمان تكتبوا another relation here، فيكم تكتبوا VBY1 equals to VBY2. يعني this is another possibility. بدل ما نكتب هون الconservation للسيستم in Y، فينا ناخد A لحال و B لحال. يعني بيطلع لنا إنه VBY1 is equal to VBY2. So عندكم option أو VBY1 equal VBY2. اصلا حيطلع لكم نفس الريزلت اكيد، لانه شو هي الايكويشن ان اذا بنعمل for the system in Y شو بيطلع لنا؟ بيطلع لنا M VA1Y M of A اكيد plus M of B VB1Y equals to, from the other side, to M B خلينا بالA أول شيء MA VA2Y اوكي plus هكتبها هون plus MB VB2Y. اوكي بس نحن قلنا هلا من شوي انه VAY1 equal to VAY2 يعني اول two terms will cancel each other فبرجع بوصل لنفس الريزلت انه VB1Y equals to VBY2. Okay, so you have here several options and in this case بتكونوا كتبتوا 4 equations with 4 unknowns فبصير فيكم تجيبوا VA2X VA2Y VB2X VB2Y. Once you know them صار فيكم تجيبوا الماgnitude والdirection. Okay, do you want me to repeat anything in the explanation here before we continue? If anything is not clear I will repeat.
دكتور
Yes.
بس نمبر 1 شو كتبناها؟
اوكي نمبر 1 يلا حارجع اكتبها. نمبر 1 هي الكونسرفيشن اوف linear momentum يعني انت بتاخذ السيستم A plus B. اوكي بما انه الكوليجن فورس هي between A and B when you take the system ما بيكون كل الاكسترنال فورس non impulsive so you can say I can apply conservation of linear momentum for the system. اوكي هيدي الكونسرفيشن بتستعملها على اي سيستم؟ على السيستم A plus B يعني بتقول I will take system A plus B. okay and I will apply conservation of linear momentum. فينا اعملها in X هي vectorial relation يعني فيك تكتب equation in X equation in Y. equation in X بتكون MA VAX at state 1 plus MB times VBX at state 1 equals to MA VAX at state 2 plus MB VBX at state 2. Okay, so this is your first relation. It is the conservation of linear momentum along X. Now, هيدي relation you can use it also in Y إذا بدكم بس مثل ما قلت لكم in Y حتعطيكم نفس الشيء إذا بتاخذوا ال A plus B أو بتاخذوا A لحال B لحال. اوكي يعني it will result in the same final result اللي هي انه VAY1 equal VAY2 VBY1 equals VBY2. اوكي بينما بالنسبه للX components هيدي الريليشن هي الايكويشن نمبر 1 للX components. ثاني ريليشن للX components بدنا نستعمل restitution coefficient لانه اللاين اوف امباكت هي الX يعني E coefficient بيكون given بالبروبلم نكتب انه E equals to VAX at state 2 minus VBX at state 2 over VAX at state 1 sorry VB من تحت بتقلبون بالعكس يعني over VBX at state 1 minus VAX at state 1 فهول التو equations اوكي بيعطوكم اي unknowns؟ بيعطوكم two equations two unknowns اللي هن VAX2 و VBX2. اوكي بيبقى two other unknowns اللي هن VBY2 و VAY2 فنجيبهم هوليك it's very simple لانه ما تغيروا ال velocities along Y. ليه ما تغيروا ال velocities along Y؟ لانه ال force of impact هي along X. اوكي clear يلي سأل السؤال؟
دكتور بس بعد شغله يعني نحن قلنا اول شيء بنجمع A plus B كسيستم.
نعم
نرجع فينا نعمل
نرجع
A
نعمل
لحال
لهم
او B لحال.
separation. مزبوط. ليش بناخذ كل وحده لحال بعدين؟ كل وحده لحال لانه للواي بالواي انت ما عندك impulsive force along y ففيك من مصلحتك تاخذ A لحال و B لحال لانه دغري بتطلع لك شو هي VAY2 شو هي VBY2. بينما اذا بتاخذ من الاول A لحال و B لحال in X ليه ما بتعمل هيك in X؟ لانه in X في impulsive force في impulse. اوكي هلا اي متى فيك ترجع تاخذ A لحال و B لحال in X؟ من بعد ما تجيب VAX2 VBX2. ساعتها اذا سالوا لك what is the impulse فيك تجيبه لانه اذا بتاخذ A إذا بناخد system A along X شو بيعطيك الريليشن؟ ما في منهم equal لأنه في impulse. أوكي؟ يعني along X عندك MA VAX at state 1 plus أو minus الimpulse إذا عم نعتبر B will act on it towards the left minus impulse of B on A is equal to MA times VAX at state 2. يعني انت اذا بلشت تاخد A لحاله هتفوت unknown جديد اللي هي الامبولس. This is why بناخد A plus B بالاول. اوكي. بينما in Y ما عندك هالمشكله لانه in Y ما في impulse اصلا، يعني in Y the velocities will not change. Any
clear,
other
doctor. Thank you.
Any other question on this? Okay. يلا حنعمل some examples هيك بتصيروا تفهموها أكثر. Okay. So as you can see هيدي الفيجر. نعم.
أنا بس عندي سؤال صغير. نحن عنا لما يكون عنا بلاستيك امباكت بيكون عنا الانرجي زيرو.
لما يكون عندنا بلاستيك امباكت يعني وعندنا complete loss of energy، يعني بنكتب انه الاي restitution coefficient is zero. اوكي. وهيدا والريزلت will be predicted لانه شو بيعطيك E equal 0 شو بتعطيك؟ بتعطيك انه VA2 equals VB2 and you can know this لانه بالبلاستيك امباكت بيصيروا one body. اوكي بيصيروا ماشيين مع بعض البولز.
اوكي ثانك يو.
ويلكم. اوكي هلا هون مثلا رسموا لكم الدايجرام اوف امبلس اند مومنتوم. هيدا الدايجرام بيساعدكم تشوفوا الايكويشنز. يعني مثلا you can see انه اذا باخذ A عندي impulse in X بس ما عندي impulse in Y. لانه ما عندي impulse in Y this means انه linear momentum in Y is conserved بينما linear momentum in X is not. This is why بالX بدي اخذ system A plus B تقدر تطلع first relation وبستعمل الريستيتيوشن كsecond relation. بينما بالY I can take A لحال و B لحال. It's easier for me than instead of taking A plus B لأنه حتى لو أخذت A plus B ما بيكفيني الإيكويشن، بيطلع لي one equation two unknowns، بضل بدي آخذ وحدة ثانية ساعتها مجبور آخذ A لحال أو B لحال. أوكي. So وقت اخذ A لحال او B لحال in Y I deduce انه MA VAY1 equals MA VAY2 لانه ما في impulse. The same for B. MB VBY1 equals to MB VBY2 since the impulse in Y is 0. بينما in X كتبنا انا وياكم من شوي الامبulse equation على A وفينا نكتبها على B نفس الكونسبت. نكتب MB VBX at state 1 plus the impulse of B on A is equal to MB times VBX at state 2. يعني انتم من بعد ما تكونوا حليتوا السيستم الاول اذا طلبوا منكم what is the impulse between A and B ساعتها فيكم تاخذوا او A كسيستم او B كسيستم. you will obtain the same result لانه by action reaction the magnitude of impulse of A on B is equal to the magnitude of impulse of B on A. Okay. Any other question before we continue? طيب. فإذا let us do some practice. So we have in this problem the bag A having a mass of 6 kilograms is released from rest at the position theta equals to 0 degrees. After falling to theta equal 90 degrees, it will strike an 18 kilogram box. If the coefficient of restitution between the bag and the box is 0.5, determine the velocities of the bag and box just after impact and the loss of energy during collision. أول شيء we should start by looking at the figure to see what type of impact we have, central or oblique impact. Okay, so here as you can see, initially we have a bag. Initially it was far from the block. We released the bag will go downward until being close to the box. So we have a certain phase before collision. هيدي الاناليسيس بدنا نعملها تنقدر نعرف what is the velocity of the ball just before hitting the box. Okay? بما انه it's a pendulum it's doing circular motion يعني at this position بما انه radius at this position اللي هو الكيبل is vertical فحتكون ال velocity of the bag horizontal. Okay? وinitially V box at state 1 is equal to 0. فإذا هيدا أكيد central impact. Okay? So you have that the line of impact هي perpendicular to contact. يعني انتو هيدا الcontact between, this is the contact line between the ball and the box. Line of impact بتكون perpendicular لل contact line. So as you can see, the type of impact هو central impact لأنه ال initial velocity هي along the line of impact. Okay, so this is why we can say here that it's a central impact. يعني we just have two unknowns. شو هن two unknowns؟ هن VA at state 2 و VB at state 2. بس تنقدر نجيب هالunknowns مفروض بالأول نجيب what is VA at state 1. قصدنا ب VA at state 1 here's the velocity just before the impact. Okay. وهيدا state هو state 0 حنسميه VA 0. Because my system initially start from rest يعني VA 0 is equal to 0. انتوا قولوا لي من previous chapters كيف تعملوا calculation ل VA 1? What can you apply?
Principle of work and energy.
Very good. بدنا نعمل work and energy. بدنا نعمل conservation of mechanical energy بما انه the only force doing work هي الweight. يعني فينا نعمل conservation of mechanical energy. Okay? So let us do it. We will do conservation of mechanical energy on the system. And we have that from conservation of mechanical energy, we can write that TA, the kinetic energy at state 0, اللي هي 0 because it's starting from rest, plus the potential energy at state 0. هلا فينا ناخذ ال gravitational reference فوق ساعتها بتكون كمان 0 because this is 0 equals to as the final state عنا the kinetic energy is half m VA1 squared, while the gravitational potential is negative because we are below the datum. We are 1 meter below the datum, so it's a negative potential. So minus mg times 1. Okay? So this equation will allow us to find the value of VA1. Once we calculate VA1, now we will apply the collision equations to get VA2 and VB2. مثل ما قلنا بس يكون central collision, we have two equations. وحدة ناخد system A plus B and we write conservation of linear momentum along the line of impact اللي هون هي X. And the second relation that you will write is from the restitution coefficient. So let us apply here. So as you can see, the first step, we apply conservation of energy to get VA1. Hey, did just, so this is just before collision. Okay, this is the velocity of A just before collision. Now, once we get VA at state 1, we will be ready to write the system of equations during collision. The first equation will be to take the system A and B. ليش على طول قلنا بناخد the system of the two to cancel out the internal force between them. يعني ال impulsive force between A and B لأنه هي unknown. لما نزيد the number of unknowns ناخد أول شيء system A plus B. In this way, the force will be internal, and therefore we can apply conservation of linear momentum in X for the system A plus B. على طول you should specify your direction. So here, for example, I considered in the positive direction is towards the left لأنه the box here, when it will reach this position, it will have a velocity like this. فيكم تخلوا أنتوا velocity positive towards the right كمان. It's يعني you can do whatever you want. Just respect your convention. Okay. هن أخذوا convention positive towards the left. يعني VA1 is positive. So, and we know that initially the block is at rest. So VB1 is 0. We replace VA1 by its value equals to M2 VB2 plus MA VA2. هلا هون ما سموا X و Y لأنه بيعرفوا إنه because it's a central impact حيضلوا ال velocities along the line of impact. حيضلوا along the line of impact velocities. So ما حيكون عندهم Y component. They will only have an X component. Now, this is the first relation. The second relation will be obtained from the restitution coefficient. Okay? So using the restitution coefficient, here also we don't have to project لأنه it's a central impact. يعني already the velocities will remain along the same direction اللي هي the x direction. We have that E is VB2 minus VA2 over VA1 minus VB1. So we can get then another relation between VA2 and VB2, as you can see here. So we obtain now a system of two equations with two unknowns, VA2, VB2, we can calculate. And as you can see, VA2 and VB2 are algebraic values, so you can obtain a negative or positive result. So here, for example, VA2 is negative لأنه A will change direction after collision, okay? بينما VB2 will be positive. So B will go towards the right, while A will go towards the left, okay? Any question on this? Okay, so let us start another problem. Just before, we still have one question. They asked in the problem, what is the energy loss during collision? How do you think we can calculate the energy loss?
We use the principle of work and energy.
No, look, never in collision ما بنستعمل يعني ال work and energy إذا بدكم بما إنه هن قالوا loss of energy يعني بدنا نشوف قد إيه فرقت ال kinetic energy of the system. يعني أنت ال work and energy بيعطيك ال work of forces. هن ما طلبوا منك ال work of forces، طلبوا منك to compute what is the loss of energy during collision. Okay? So what you will do, you will compare the initial kinetic energy to the final kinetic energy of the system. So since we know that the initial velocity of B is 0, we can compute the initial kinetic energy by just, so KE at state before collision, KE1 is equal to half MA times VA1 square, okay? While at the final state, KE2 هتكون equal the summation of kinetic energies of A and B, and it's equal to half M VA2 square MA أكيد MA VA2 square plus half MB VB2 square. And of course KE1 will be equal than KE2 لأنه you will have some losses because as you can see here the restitution is smaller than 1. يعني لو كان equal to 1 مفروض ال kinetic energy at state 1 تكون equal لل kinetic energy at state. Okay? So here, if you do the difference, you will see the amount of energy lost during this collision. Okay? هلا إذا بدكم كمان يعني ال energy lost فيكم تقولوا إنه هي equal لل work of forces كمان. يعني it can be seen in this way. So you can see that sum of work of forces from 1 to 2 represent the energy loss. بس هن equal لبعض. Okay? بس هو وقت يسألوكم what is the amount of work done by forces فيكم دغري تقولوا ال work and energy. إذا بس طلبوا ال energy loss فيكم تقولوا إنه هي ال variation in kinetic energy direct. Okay? هلا عادة إذا كتبنا energy lost اوكي بناخذ ال absolute value لأنه بنعتبر إنه قلنا إنه it's lost يعني أكيد it's negative. Okay? Okay. Another problem. Now we will see another case. نحن شفنا إنه في central و oblique impact. So now we will see the case of oblique impact. We have in this case two smooth disks A and B having mass of 1 kilogram and 2 kilogram respectively, and they collide with the velocities shown. If the coefficient of restitution for the disks is E equals to 0.75, determine the x and y components of the final velocity of each disk just after collision. So here we have two disks A and B. and we know their initial velocities completely. We know their magnitude. We know their directions. Okay. So at state 1, we know everything about the velocities. So we just need to find the final velocities. So we have here, as we said before, we have 4 unknowns. شو هن ال 4 unknowns؟ نحن عنا we can predict إنه after collision كل بول يمكن مثلا ال A تروح هيك وال B تروح هيك let's say. اوكي. هلا نحن الدايركشن فينا ما نكون بنعرف هي كيف، يعني نحن we will assume فينا نكتبها اذا ما بنعرف اذا رح تروح to the right او to the left it's fine، نتركها نحن x و y. اوكي. ومن الكالكوليشن الفاليو النيجاتيف بتفرجينا اذا كانت نيجاتيف مثلا in x يعني رايحه towards the left، اذا positive رايحه towards the right. Okay. So if you want now we can just say that we have several unknowns. الunknowns هن اول شيء for A VAX at state 2. but we can say انه منطقيا مثلا بعد الكوليجن اذا راحوا بهيك مثل ما نحن حاطينهم انه we can predict انه VAX2 حتكون negative VBX2 حتكون positive. فينا نتاكد بالكالكوليشن. اوكي. and we have VAY2. هلا في شغله بالنسبه ل VAY2 فينا نكون اكيدين انه حتكون upward. you know why؟ لانه مثل ما قلنا قبل اللاين اوف امباكت هي اللاين along which بيصير في الكونتاكت، بيصير في الفورس between the two balls. okay. so بما انه in y no impulsive forces, this means that the y components of velocity will remain the same. يعني VA1y مش هي 3 sin 30 فكمان VAY2 حتضل 3 sin 30 حتكون upward. اوكي. وبما انه كمان in x VB1y along VB1y is minus 1 cosine 45 او sin 45 هي ذاتها، فاذا اكيد VB2y حتكون نفس الشيء. اوكي. يعني بالنسبه للy components I can directly calculate them لانه عندي conservation of momentum along y. يعني VA2y و VB2y I can directly get them. يبقى لي عندي two unknowns اللي هن VAX2 و VBX2. I need two equations. So مثل ما قلنا in the explanation بالmaterial, the first equation will be to take the total system A plus B and write the conservation of linear momentum on A and B. And the second equation will be to use the restitution coefficient, which is given here. Okay. So let us see the details. So the first step is to find what is given. We know if we go back to the figure here, معنا magnitude of velocities تبع VB1 و VA1 ومعنا directions. So we can just decompose انه VA1x هي VA1 cosine 30 و VA1y هي VA1 sine 30. While for VB it has a negative component along y, negative component along x, both components are equal in magnitude لأنه الانجل 45 degrees. So VB1x هو minus 1 cosine 45 and VB1y is minus 1 cosine 45. So here, as you can see, we determined the initial velocities of A and B, and we have done a small scheme to help us in the interpretation. هيدا scheme بيبين لنا impulse diagram of impulse and momentum. Okay. فإذا هيدا هون we have, this is the initial momentum diagram. So this is initial momentum diagram. In this diagram we represent the initial velocities. Here everything is known in the initial state. Okay. حد المومنتم diagram نرسم الامبulse diagram. The impulse diagram will represent impulse of all forces acting on the particle. So here بما انه الcontact between A and B the contact line is along y فالimpact line بتكون along x. This is why here your impulsive force will be along x. So this is called the momentum diagram, sorry, the impulse diagram. So this is the impulse diagram. And finally, at the final state, هيدا الفاينل momentum. So this is the final momentum diagram. So we, in this case, we have two unknowns, MA VAY2, MA VAY2, VAX2. Okay? Concerning VAY, you can directly see from the diagram إنه ما في impulsive forces along Y. So MA VAY1 VY1 equals MA VAY2. يعني VAY1 equals to VAY2. So we can directly say that this is equal to VAY2. And the same for B. This is equal to VBY at state 2. Okay? Now, I move to X components. In X, لأنه في impulse in X, ما حاخد A لحال أو B لحال. حاخد the system A plus B to remove the impulse that is unknown. Okay? So, when I take system A plus B, I will have this. Sorry guys, 1 minute. Okay, so first I can apply the conservation of linear momentum along X. So MA VAX at state 1 plus MB VBX at state 1 equals to MA VAX at state 2 plus MB VBX at state 2. So I replace VAX1 and VBX1 by their values. Then I am left with one equation with two unknowns. This is my equation number 1 relating X components. I need a second relation, so I will use the restitution coefficient. But please here pay attention. As we said, always the velocities and restitution coefficient in the projection along line of impact. Well, line of impact هي X, so I take VBX at state 2 minus VAX at state 2 over VAX at state 1 minus VBX at state 2. Keep in mind, please, في كتير بيغلطوا بيحطوا magnitude of velocities. No. بالrestitution coefficient بنحط algebraic value of projection على line of impact. Okay? يعني ما فينا نحط VB magnitude at state 2 minus VA magnitude at state 2. It's wrong. بدنا ناخذ component of projection on the line of impact. So from here, replacing VAX1 and VBX1 by their values, we get a relation number 2 between VAX2 and VBX2. So we end up with a system of two equations with two unknowns that can be solved. Okay? Any question on this? Okay. Now, another section in this chapter is angular momentum. So until now, we have talked about linear momentum. Now we will introduce angular momentum. Okay? In case of angular momentum, we should define first what is angular momentum. Angular momentum represents the moment of the linear momentum vector. Linear momentum هو vector mv. Okay? So this is vector mv. You know how to calculate the moment of a force. حيلا force, حيلا vector. إذا بدكم تعملوا المومنت تبعه about a point. You can do it in several ways. فينا نعملها إذا كان simple figure. If we know the distance between the vector will axis, let's say you want to get the angular momentum about the axis. All you have to do is to take the perpendicular projection D, and you say that the magnitude of the angular momentum حتكون D times the magnitude of the vector mv. Okay? وتتعرفوا الساين if it's along positive z أو negative z بنعمل right hand rule. يعني مثل ما كنتوا تعملوا moment of forces نفس الكونسبت، بس هون بدل ما اخذ moment of a force عم باخذ moment of a vector يلي هو linear momentum mv. So this is the definition of angular momentum. It represents the moment of the linear momentum. Now, how we use it, we will see in this section. So first, if you want to use scalar formulation, you can say that the magnitude of the angular momentum is given by m times v times the distance to the axis of interest. And For the direction, you can get it from the right-hand rule. So this is the first method. You can use also a vectorial formulation in case you are working in 3D and it's not clear, it's not easy to determine the moment. You can use the vectorial formulation. You know that to find the moment of a vector, I do r vectorial the vector. What is r? R is the position vector from the point of interest. يعني إذا أنا عندي vector mv and I want to find its moment about O, the technique is to take a position vector from O towards any point on the vector فيكم تاخذوا، مش ضروري point of application. Any point on the vector أخذتوها بالstatics أكيد. Okay? So you can take from O to any point on the vector. This is the position vector R, and you do R vectorial mv. When you do this vectorial product, you will get the moment of the vector about the point O. So here, because it's a vectorial product, you can calculate it using the matrix method. So in the matrix method, you have ijk vectors. You have for the first line, you have the position vector. For the second line, you have the linear momentum vector. Okay. And the technique is very simple. You put plus above I, minus above J, and plus. أكيد بتعرفوا تعملوا calculation la matrix. I will remind you of the method. Yeah, along I, and the plus Ry times MVZ minus MVY times RZ. Along J, I have minus J times, يعني على طول you drop. وقت أخذ J, I drop line والcolumn of J. بيضل عندي Rx MVZ minus RZ MVX. بس ما تنسوا تحطوا الماينس قبل ال J component. Finally, for K component, كمان I drop column and line of K. وعندي plus, so it's plus K times Rx MVY minus Ry MVX. In this way, I can calculate the angular momentum about point O. Now, how we use the angular momentum in practice, we will see together. أول شيء, we will derive a relation between sum of moment about a point will angular momentum. Okay? If we go back to the definition of forces, summation of forces is equal to what? Summation of forces is equal to the mass times the acceleration A. And we know that A vector is dv by dt, v dot, okay? When it's a bold letter and it's a vector. So, and by definition, sum of moments about O is R vectorial sum of forces. And if you want to do the moment, if you have anybody, okay, and you want, it's subjected to several forces, وبدكم تجيبوا المومنت of these forces about a point, what is the technique? You replace the system of forces by a force at the center of gravity, let's say. هلا نحن بعدنا عم نحكي بparticle, okay? نحن بعد ما وصلنا ل rigid body. In next chapter حنبلش ب rigid body. So here we have just a particle, يعني all forces are applied on the particle. So you have sum of forces vector will pass by the particle. So if you want to assess what is sum of moment of these forces about any point in the space, you should take the position vector حيكون من all الparticle. So OP. So I have OP vectorial sum of forces. And since sum of forces can be replaced by MV dot, okay? So you can say that sum of moment about point O is equal to R vectorial MV dot. Okay. Now we will demonstrate together that R vectorial MV dot is equal to the derivative of angular momentum. Let us derive this. Because what is the definition of angular momentum? شفنا سوا انه الانجلر مومنتوم هو R vectorial MV. خلينا نجرب نعمل له derivation. إذا بنعمل d by dt of R vectorial MV, it is R dot مثل كأنه U times V، نفس الكونسبت بالفيكتوريال. يعني عندي R dot vectorial MV plus R vectorial MV dot. But you know that R dot is what? R dot is dr by dt هي V. And V vectorial V is 0. So this term will cancel out. So the derivative of angular momentum, h dot O, is nothing than r vectorial mv dot. Okay? And if you compare the two expressions, you can conclude that the derivative of angular momentum is equal to the summation of moments about O. So summation of moments about O is equal to the derivative of angular momentum with respect to O. Okay? Any question on this? Okay. Now, what if I have a system of particles? So also if I have a system of particles, I can apply that, the same concept. So مثل ما عملنا الdemonstration بالنيوتن law. So for each particle, I will consider the external forces and the interaction forces with other particles. بس وقت بيجي باخد كل السيستم شو بيصير بالinteraction forces Fi? They will cancel each other due to the principle of action reaction. This is why مثل بالنيوتن law نفس الشيء هون. I can say that if I take a system of particle, I can also write إنه summation of moments about O is equal to the derivative of the angular momentum لأنه هيدا الترم تبع internal forces حيروح ما بيبقى إلا moment of external forces. So in case I have a system of particles, I can say that sum of moments about O is equal to the derivative of the total angular moment. Let us see a small example on how to use this concept. We have the box of mass m is traveling down the smooth circular ramp such that when it is at the angle theta, its speed is v. Determine its angular momentum about point O at this instant and the rate of increase in its speed. So in this problem, we want to determine, using the angular momentum concept, what is AT. So let us go back to the definition. أول شيء what is angular momentum here? عندنا rotation, it's a circular motion. So vector velocity is like this. Always tangent to the path. So this is vector mv. So I can say here that if I want to find the angular momentum about O, I should find the moment of mv about O. So I should find the distance between O and mv. So since mv is perpendicular to the radius, so the distance to O is equal to r. And to know the direction, from right-hand rule, if I do the right-hand rule, the corresponding angular momentum will be clockwise. Okay? So I can write that HO is clockwise equal to mv times r in the clockwise direction. Okay? So this is the value of the angular momentum. Now, if I use the principle derived on angular momentum, we have seen that sum of moments about O should be equal to the derivative of angular momentum about O with respect to time. So let us derive together the expression we got. During circular motion, you know that R will not be varying because it's a circle. And M is constant, so I only have to derive V. So I can write that sum of moments about O is equal to the mass times R times dV by dt. And the derivative of velocity with respect to time in circular motion yields tangential acceleration. So I can deduce that sum of moments about O is equal to M times R times the tangential acceleration, AT. Now, how to get AT? I will find what is sum of moments about O. To find sum of moments about O, I should draw the free body diagram of my particle. So let us do it. This is my particle. What are the forces acting on it? I have the weight, W, and I have the normal reaction, N. So as you can see here, while moving through the circular track, n is always passing by the center of rotation O. So no moment for n about O. I will only have the moment of the weight. And to get the moment of the weight about O, I should find what is this distance here. The perpendicular distance from O towards the line of action of the weight. This distance is simply r sine theta. So now, if I replace in my equation, and as you can see also, the moment of W is clockwise about O. So since I consider the clockwise direction as positive, I can write that plus mg, which is the weight, times r sine theta. This is the moment of the weight about O. And we don't have any other moment since n passed by O, is equal to the derivative of angular momentum, which is mr times at. So as you can see here, m and r will be simplified. So I deduce that at is equal to g sine theta. And I could have demonstrated this result in another way by using sum of t equals mat. This is another method. يعني هيدي first method by using the angular momentum. وانتم حتلاحظوا انه بكل هول chapters you always have several methods. يعني نحن شفنا انه a same problem can be solved using work and energy او using combination of 12 and 13. كمان شفنا بالناو بالchapter 15 انه فينا نستعمل linear momentum او كمان كان فينا نستعمل combination of 12 and 13. So always we have several methods to use, but sometimes they force you to use a method, so you should know all methods. Okay, now in case بدنا نعمل Newton law مثلا, all we have to do, we can say that this is ut, this is un, so this is tangential vector, this is the normal vector. So if I am interested in AT, I should write that sum of FT equals MAT. And as we mentioned previously, the two forces are the normal. Normal here along UN, يعني ما بتأثر على tangential acceleration. And we have the weight that is W, that is doing with this line with UN, it's doing theta. And with UT, it's doing 90 minus theta. So if I want to project the weight on UT, حيكون عندي mg sine theta equals to MAT. فرجعنا the same result. If you simplify M, you will get that AT is equal to G sine theta. So same result obtained from angular momentum relation. Okay, any question on this? Okay, so let us continue. Now, another very important aspect of angular momentum مثل linear momentum. شو تعلمنا؟ بالlinear momentum we have seen and we can apply the principle of linear impulse and momentum. كمان نفس الشيء بالangular momentum we have the principle of angular impulse and momentum. The method of demonstration is the same مثل linear momentum. يعني I go back to the definition. نحن لقينا انه sum of moment about O هي dHO by dt. So if we do separation of variables, إذا بناخد dt to the other side, okay, بيطلع لنا انه sum of moments about O times dt is equal to dHO. And now if we integrate both sides of this relation, okay, what do we get? We get that summation of integral from T1 to T2 of MO dt is equal to the variation of angular momentum HO2 minus HO1. Okay, now what can we deduce from here? We can deduce مثل ما عندنا linear impulse and momentum formula, عندنا نفس الشيء. فينا نقول انه sum of angular impulses, so هيدا الترم بنسميه angular impulse, is equal to the variation of angular momentum. يعني by analogy مثل ما عندنا هونيك sum of integral f dt equals mv2 minus mv1 هون عندنا sum of integral t1 t2 m moment dt اللي هو اسمه الانجلر impulse equal to الانجلر impulse at state الانجلر momentum at state 2 minus الانجلر momentum at state 1. Now, and in case sum of moments about O0 يعني في عندنا cases بيكون sum of moments about O0 ساعتها بيصير عندنا مثل ما عندنا هونيك conservation of linear momentum if sum of forces equal to 0 هون عندنا conservation of angular momentum if sum of moments about O equals to 0. So here you can see it here. So in case I have, so هول as we said هول هن linear impulse and momentum theorem وهيدا angular impulse and momentum theorem. And in general in some problems you might need to use both. هنعمل كتير examples and you will see how. And always إذا عم نحكي ب 2D motion يعني in XY linear impulse and momentum بيعطيكم two equation وحدة in X وحدة in Y. But the angular momentum بيعطيكم one equation. You know why? لأنه بس يكون عندكم 2D motion يعني كل ال forces in X, Y المومنت بيكون only about what? Only about Z. لأنه you know if I have a plane all forces in the plane cannot do moments about X and Y. They can only do moments about Z. Okay? فوقت يكون عندنا 2D motion linear impulse and momentum بيعطينا two equations بينما angular impulse and momentum بيعطينا one equation اللي هي perpendicular along the axis perpendicular to the plane. يعني إذا نحن عم نحكي بmotion in XY بتكون sum of moments about Z and we can just write one relation from angular momentum. هنشوف بعدين سوا إن شاء الله next semester okay or next year انه in 3D we can apply ساعتها three equations of angular momentum, one in X, one in Y, one in Z. While in 2D we can just apply in the direction perpendicular to the plane of motion. لأنه sum of moments along X و along Y بيكونوا zero. Okay? And now, as we said in particular, if sum of moments during the interval from T1 to T2 about a certain point is 0, then we obtain HO at state 1 equals to HO at state 2, which is named as the conservation of angular momentum. So if no external impulse is applied to the particle, both linear and angular momentum is conserved. يعني إذا sum of forces equals 0 and sum of moments equals 0, then all impulses are 0, linear and angular. ساعتها بصير في conservation of linear momentum و conservation of angular momentum. Please انتبهوا أوقات بيكون في conservation of angular momentum but not conservation of linear momentum. Why? لأنه أوقات بيكون في forces وعندهم impulse بس المومنت تبعهم about O0. ساعتها بالlinear momentum ما بيكون في conservation لأنه في impulsive forces بينما بالangular momentum بيكون في conservation لأنه هول الimpulses ما عندهم moment about. Okay? So it always depends on the case you have. Let us now we will do some examples to practice on conservation of angular momentum. In general عطول بس يكون عندكم central force think about conservation of angular momentum. Why? لأنه at any position your force is passing by one point. يعني هيدي force will never have a moment about O. So in central force motion you can say we have conservation of angular momentum. هيدا example تاني مثلا. In this بالplayground, okay? In this case the forces acting على occupant هيكون الnormal والweight. But as you can see the weight is parallel to the axis of rotation يعني ما عنده moment والnormal على طول passing by the axis of rotation يعني no moment. So we can deduce that in this case also we can apply conservation of angular momentum about Z. Okay? Let us see now some examples, other examples. Let us do this problem together. So we have the 0.4 kilogram ball B is attached to a cord which passes through a hole at A in a smooth table. When the ball is at 0.5 meters from the hole, it is rotating around in a circle such that its speed is V1 equals to 1.2 meters per second. By applying a force F, the cord is pulled downward through the hole with a constant speed of 2 meters per second. هيدا اجاكم بالاكزام هو ذاته تقريبا a problem that is very close to it. بس بالاكزام انتم ما كنتوا بتعرفوا تعملوا conservation of angular momentum بس تعملتوا other technique to solve the problem. Here we will see that we can solve this problem using the concept of angular momentum.
انا
Okay?
جربت اعملها using الانجلر مومنتوم، مش عارف اذا ظبطت او لا.
طب ما انت ما
عملت حسب
يعني بتعرفوا
الترمينال.
من قبل بتعرفوا من سكول الانجلر مومنتم.
ايه بس بفتكر طلعت غلط، طبست كتير فيها.
بس انت مش عايزه يعني هون بتعرف ليه؟ لانه كان عندك information enough تقدر تحله بلا ال conservation of angular momentum. كان المفروض تعمل ال work and energy theorem. اوكي وكان المفروض تستعمل لانه central force، ما هن قالوا لكم ساعدوكم قالوا لكم it's a central force motion وساعدوكم زياده قالوا لكم find the constant of area. يعني بما انه انت بدك تجيب h is constant معك اياها اوكي و you know انه once you get h you can get theta dot at any position مظبوط لانه انت عندنا h هي r squared theta dot. اذا r squared theta dot is constant at any value of r I can compute theta dot. صار معي theta dot تلاقي الفيلوسيتي بيبقى بس جيب ال r dot صح؟ فانا من ال work and energy بجيب الفيلوسيتي ساعتها صار معي v ومعي theta dot I can get r dot لانه v هي decomposed into vr and v theta. هيك لازم تحلوه بالاكزام. هلا here in this problem here we will see انه الانجلر momentum بخلينا نحل البروبلم. Why? Because here it's a central force motion. Whenever I have a central force motion I can apply conservation of angular momentum about the axis. يعني أنا هون at any time the force is passing by A صح؟ So it's a central force. Since it's a central force problem هيدي الفورس will never do a moment about A والother forces هن الweight والnormal reaction واثنيناتهم parallel to Z. يعني in total no external moment about A. يعني إذا بعمل sum of moments about A or sum of moments about Z axis it will be equal to 0. Since sum of moments about Z is 0 then I can apply conservation of angular momentum about Z. يعني H about Z at state 1 will be equal to H about Z at state 2. Now, let us see what do we know. What we know in the problem is that initially, at the initial state, قبل ما نبلش نحط force على الكيبل, the velocity was 1.2 meters per second perpendicular to R1. Okay? R1 is given to be equal to 0.5 meters. I think let us make sure. So what we know in this problem is that R1 is 0.5. We know Z1 is 1.2. And we know that the cord is pulled through the hole at a velocity of 2 meters per second. This is what we know. So if we go back to the figure, at the initial state, we can calculate the angular momentum because we know that at the initial state, R1 is perpendicular to the velocity. So the initial angular momentum حيكون m times v1 times r1. Okay? So we can say that h about z at state 1 is equal to r1, which is given 0.5 times the mass times v1, which is 1.2. So at state 1 we know everything, so the angular momentum is known. Now, from conservation of angular momentum, we can say that this should be equal to the angular momentum about z at state 2. Now, for state 2, here is the challenge for state 2. For state 2, we know the radial velocity Vr, which is pulling inward the cable. So why we can think here about Vr and V theta? Because look, you have a problem where you have always your vector is directed towards one point. So I can consider that UR will be from A towards the particle. So this is my UR vector. And here I know VR is negative because I'm pulling inward. So VR dot is 2 meters per second. So here VR is given, but I don't need VR للangular momentum لأنه VR is passing by A. What I need for the angular momentum هو الcomponent perpendicular to R. Component perpendicular to R هو ال V theta. Okay? Which is R theta dot. So بما انه انا ما بعرف V theta رح جيبها من conservation of angular momentum. لانه moment of V2 about A هي ال V theta at state 2 times R2. لانه V theta هي ال perpendicular to R while VR is along R2. This is why VR will not have a moment about A, only V theta. And the moment of V theta about A is simply calculated as في تتا ام في تتا اكيد لانه احنا على طول بنعمل angular momentum هو المومنت اوف linear momentum يعني المومنت اوف ام في تتا. So vector m v theta is perpendicular to R2. This is why angular momentum at state 2 هيكون equal to R2 times m times v theta at state 2. Okay? So from this relation the only unknown is R theta dot اللي هي V theta at state 2. So I can calculate, once I calculate V theta at state 2 and I know the value of VR اللي هي R dot اللي هي 2 meters per second, I can get the total velocity at the second position. So it's radical V theta square plus VC square. Okay? And now once I determine the speed اللي هو radical, the speed at state 2 هو radical V theta 2 اللي هي جبتها من conservation of angular momentum. Okay. Plus radial velocity VR بس قلنا انه VR هي equal to minus VC. Okay. لانه هي الكومبوننت inward هو R dot هو VC and it's negative لانه opposing UR. بس اصلا ما بيهمني اذا negative او positive لانه بالmagnitude it will be square, so it's plus VC square. This is how I calculate the speed by decomposing it into two components, V theta and VC. And once I get the speed, I can now find what is the amount of work done by F in shortening the radial distance. لأنه طلع الwork بعمل principle of work and energy. I can say that the work done from position 1 to position 2 is equal to the variation in kinetic energy. اصلا the only force doing work هي F لانه الweight والnormal perpendicular للmotion, so they will not do any work. So the only work done is by F, and I can calculate this work by applying the principle of work and energy. So work of F is kinetic energy at state 2 minus kinetic energy at state 1. And all of these can be seen here in the details of calculation. So the first step, as we said, as you can see here, we decompose the velocity into two components. One radial component directed towards the center, A, and one perpendicular to R, which is V theta. The component perpendicular to R is calculated from conservation of angular momentum. The component along UR is VC, okay? So now from angular momentum conservation, I get V theta, and VC is given, so I can calculate the total velocity by doing radical of V theta square plus VC square. Once I get the velocity, I just have to apply the principle of work and energy, and I can get what is the force, what is the work required to go from state 1 to state 2. Okay? Any question on this problem? اوكي سو هيدا ما بعرف انتم اذا هول السلايدز اكيد معكم اياهم، بس بليز البارت الباقي you are not responsible of it. يعني من بعد slide 69 هيدا الفاينل سلايد. Okay, so this is chapter 15. We are done with the material of chapter 15. هنبلش نعمل review problems okay on this chapter.
هدول مش مسؤولين عنهم يعني؟
نعم.
هدول مش مسؤولين عنهم يعني؟
لا، يلي بعد سلايد 69 منه بالبروجرام. اوكي ما عندكم اياه. يعني انتم اذا
بس
عندكم
فيك تقول لنا
سلايد
هي
كلهم.
شو الرقم تبعه؟ من فوق
نعم.
15.2. نحن ما عندنا، مش مرقم السلايد عنا، اذا فيك تقول لنا 16.2.
اوكي اخر سلايد 15.14.
اوكي
example
example.
15.14 yes.
Okay, thank you.
Okay. So now we will start with the problems. Yeah, let me just open the file. You see the file of problems? Guys, do you see the file of
Yes, Dr.
problems?
Maria. Yes.
Okay. The boy B jumps off the canoe at A with a velocity VBA relative to the canoe as shown. If he lands in the second canoe C, determine the final speed of both canoes after the motion. Each canoe has a mass MC, and the boy's mass is MB, and the girl D has a mass MD. Both canoes are originally at rest. I will re-explain the given. So what we have here, we have two small boats, okay? Initially the systems are at rest. يعني كان كله الفيلوسيتي تبعهم zero. What will happen is that boy B, okay, will run towards the second boat. يعني he wants to do a jump and he will land on the second boat, okay? The question is, what will be the velocity of the system, يعني of the boat of A and C after the jump? In this problem, we should decompose the analysis into steps, okay? أول شيء, initially the system is at rest. When B will run, it will have a certain velocity, okay? ليش لازم نفكر بالlinear momentum هون؟ لأنه عندي system بعرف الinitial velocity تبعه وفجأة تحرك part منه، okay? So if I consider the system أول شيء of both A plus the man, okay? هيدا السيستم بعرف الانيشال مومنتوم تبعه، الانيشال مومنتوم تبعه كان زيرو لانه it was at rest. طيب do I have any external forces؟ اذا عندي الاكسترنال فورسز على السيستم in X ما قالوا لي انه في فريكشن او شيء مع الووتر ليفل، ما حكوا عن فريكشن. So بما انه ما حكوا عن فريكشن بين الووتر ليفل والبوت I can consider that in X direction, okay, I have conservation of linear momentum. بما أنه عندي conservation of linear momentum in X for the system A plus B, let us apply it to find what will be the final velocity of the man and the boat. Okay? هن عطوني information تاني كمان اللي هي relative velocity. قالوا لي إنه the man will jump at a velocity relative to the canoe equal to 5 meters per second. يعني هن ما عطوني ال final velocity of the man بس عطوني ال relative velocity between the man and the boat. So this is VB relative to A. بس please انتبهوا بالconservation of linear momentum كل الvelocities absolute. اوكي يعني انا بس اكتب linear momentum equation all velocities involved in this linear momentum relation are absolute velocities. يعني انا بدي اجرب I should link the absolute velocity of B to relative velocity given. احنا بنعرف من chapter 12 انه relative velocity can be used to relate the two velocities. يعني عندي VB relative to A is VB minus VA صح؟ So I will use it to express VB function of VA. بما انه هن اعطوني relative velocity so I can write that VB can be written as VA plus 5. Okay, and now so this will give me the absolute velocity of B. Okay, so now when I write the conservation of linear momentum, initially the system is at rest يعني كانوا اثنيناتهم zero, so initial momentum is 0. Final momentum after the jump, okay, صار عندنا for the canoe, for the small boat عندي velocity VA to calculate, so it's M boats times VA plus MB times VB. بس please انتبهوا نحن عم نعمل هيدي conservation of linear momentum in X direction صح؟ So all velocities calculated are along X. So this is why I should make sure here to project my velocity along X. So here I should do the projection is since VB relative to A has a certain direction that has X and Y component. بما انه انا عم بعمل relation along X, I should project this relative velocity along X. Okay, so I have VA plus, I should add plus VB relative along X. VB relative along X is VBA cosine theta. يعني هون إذا بدكم لازم ما ننسى نزيد لأنه منا لو كانت الفيلوسيتي relative horizontal ساعتها دغري بكتب plus VB relative to A. Okay, بس بما إنه it's inclined I should decompose it into X and Y component. The X component is VBA cosine theta والY component هي VBA sin theta. هلا الY component حيساعده تيعمل الجump يعني لأنه تيقدر ينط to go to the other boat. Okay, so here in this relation the only unknown is VA لأنه ال V relative is given, the angle theta is 30 degrees is given. The only unknown will be VA, so I can get VA from this first relation. Okay, now once I got VA, I can deduce what is the velocity of B and X just before hitting boat C. Okay, and now the second step, the man will jump on boat C. But you know that it's like a projectile motion, صح؟ بالprojectile motion, the X component will remain the same. So the X component is not changing. يعني هيدي VBX just after collision هون اللي جبتها هون هي ذاتها the velocity of B and X just before landing on boat C. Okay, so just before landing on C كانت الجيرل and كانوا at rest. يعني على initial state إذا بدكم عندي هولي equal 0 velocity تبعهم while B عنده VBX اللي هي calculated from the previous step. So all I have to do for the initial state تبع second phase, I replace mass of B times velocity of B in X. إذا هيدي سميناها إذا بدكم VBX1 هي ذاتها حتكون هون VBX1 equals to the final state اللي هو لما يصيروا ال B, C وال D at one velocity لأنه هو حينط عليهم وخلص بعدين ما حيقعد في relative motion حيمشوا سوا. So at the final state B, C and D will be one object with one common velocity. So at the final state عند the final linear momentum حيكون mc plus mb plus md times vc. The only unknown in this equation is vc, so I can get the value of vc. In this way, I calculated the velocity of both A and the velocity of both C after the jump. Okay? Any question on this? Another problem. Two smooth coins, A and B, each having the same mass, slide on a smooth surface with the motion shown. Determine the speed of each coin after collision if they move off along the dashed path. Hint, since the line of impact has not been defined, apply the conservation of momentum along X and Y respectively. أول شيء هون هن عادة بالإكزام ما حيعطوني هنت. أوكي أنا كيف لازم أفكر؟ شفنا بالبروبلمز بالكورس ماتيريال إنه one possibility بس يكون عندي oblique impact إنه هن بيعطوني line of impact. طيب بس يعطوني line of impact بعرف إنه along Y عندي conservation of velocities. هون ما قالوا لي شو هي line of impact، يعني عندي مشكلة منشان هيك أعطوني extra information. هتشوفوا شو هي الإكسترا information اللي أعطوني إياها. إذا بتطلعوا بالgiven first they gave me the magnitude of velocity at state 1 و they gave me هيدي VA1 is given. مش بس in magnitude كمان بعرف الدايركشن لأنه عطوني C و D، يعني C و D here are given, so I can conclude الانجل هون. So for VA1 ما عندي ولا مشكلة, I know it completely. Now for VA2 ما بعرف الماجنتيود بس لأنه ما بعرف اللاين اوف امباكت اجباري يعطوني extra information, لأنه أنا لو بعرف اللاين اوف امباكت بيصير عندي extra equations اكتبهم, بس بما أنه I don't know the line of impact I need extra information from their part to be able to solve the problem. من هيك عطوني الدايركشن of VA2, يعني قالوا لي إنه بتا is 45 degrees, فبتا بطلت unknown, بتا is no. اوكي, الunknown بالVA2 هي just الماgnitude. Now concerning VB1 كمان مع الماgnitude ومع الانجل gamma, so I completely know VB1, while for VB2 ما بعرف الماgnitude بس كمان لأنه ما عطوني اللاين اوف امباكت جبروا يعطوني additional information, عطوني الانجل of VB2. يعني in total I just have two unknowns only. Okay, so here I just need to write two equations. شو هن two equations اللي لازم اكتبهم؟ بهيك case بما انه ما بعرف اللاين of impact, يعني ما بعرف اللاين along which I have the impulsive force, مش من مصلحتي اخذ A لحال او B لحال. The best option is to take the system A plus B. ساعتها I apply conservation of linear momentum على السيستم, وبما انه ال conservation equation is a vectorial relation فيني اطبقها in x وفيني اطبقها in y, فساعتها بيصير عندي two equations, two unknowns. Okay, and you will see here انه vy ما حيكونوا conserved لانه ال line of impact مش x. لو كانت ال line of impact along x بيطلع انه VAY1 equals VAY2, بس هون هن ما حددوا لي line of impact. It can be anywhere between x and y. هلا حنشوف سوا انه now after performing the calculation I can determine myself how will be the line of impact. Okay, so the strategy is, since I just have two unknowns and I don't know where is the line of impact, I will write conservation of linear momentum in x والconservation of linear momentum in y. خلينا نعملها أنا وياكم in detail. أول شيء أول equation حتكون this one. This is conservation of linear momentum in x. شو بتقلي ال conservation of linear momentum in X؟ هلا هون لانه قالوا لي انه the mass of A and B is the same، هن عملوا دغري simplification للان، اوكي؟ لانه MA equals MB يعني الماس بتروح من الايكويشن. So انا حاكتبها بس انه at the end we can simplify. So initially عندي MA times VAX times VAX at state 1 plus MB times VBX at state 1 equals to MA times VAX at state 2 plus MB times VBX at state 2. Okay. So this is the conservation in X. Now, since the mass equal MA و MB فينا نعمل simplification للماس. So بيصير عندنا انه VAX1 plus VBX1 equals to VAX2 plus VBX1. Now let us replace each component. What is VAX1? If I go back to the figure, it's a negative component. So it's minus VA1 times what? Cosine of this angle. What is cosine of this angle? It's C over the hypotenuse اللي هي radical C square plus D square. So هيدا هي إذا بدكم إذا سمينا هيدا الانجل التتا هيدي cosine of theta. C over the radical. Now for VBX come in VB1 as you can see here and the negative component along X وبما انه الانجل with Y is gamma يعني البروجكشن هي minus VB1 sin gamma. So this is VBX, it's minus VB1 sin gamma equals to for VA2 ما بعرف الماجنتيود بس بعرف من الفيجر انه هي negative component لانه هي upward هيك. So and we know the angle beta, so it's minus VA2 sin beta. So minus VA2 sin beta. While for VB2, كمان it's negative and it's doing an angle alpha with X. So it's minus VB2 cosine alpha. So this is a first relation involving our two unknowns اللي هن VA2 and VB2. Now we will repeat the same procedure in Y direction. Okay? In Y direction, all we have to say عندنا MA VAY1 plus MB VBY1 يعني just we should replace X by Y. Okay? بيصير عندنا تاني equation اللي هي conservation of linear momentum along Y. كمان الماss is simplified. Now we will replace the velocities. To start with, if you look at VAY at state 1, it's a negative component. It's minus VA1 times sine of the angle. Sine هو D over, sine theta هو D over radical C square plus D square. بالنسبة ل VB1, the projection on Y هي VB1 plus VB1 cosine of gamma. بالنسبة ل VA2, it's a positive projection. هي plus VA2 cosine beta. وبينما بالنسبة ل VB2, it's a negative component in Y. ولأنه الأنجل مع X هو alpha يعني it's minus VB2 sin alpha. So as you can see here, just we replace in the equation. So this is D over radical هو sin الأنجل theta. ومثل ما قلنا هون ال projection of VB, VA2, VB2 along Y. So now we just have to replace alpha, beta, gamma by their values which are given. يطلع لنا system of two equations with two unknowns اللي هن VA2 و VB2. So we can solve for VA2 and VB2. هلا أنا بدي زيدلكم extra question. إحنا جبنا هلا ال VA2 و VB2. If I ask you conclude the direction of the impact line, of the line of impact. كيف فيني أجيب هلا ال line of impact؟ أول شيء تذكروا شو definition of line of impact؟ along the line of impact بيصير فيه collision force. اوكي يعني اذا collision force along the line of impact يعني impulse كمان along the line of impact. يعني اذا بقدر لاقي impulse vector direction تبع impulse vector هي بتكون direction تبع line of impact. كيف فيني اجيب impulse vector? What should I do to get the impulse vector? إذا أنا قلت لكم calculate the impulse between A and B شو بتعملوا؟ فيكم تاخدوا A plus B as system sheet اثنيناتهم مع بعض؟
ناخد يا A يا B.
Very good. ناخد يا A يا B. اوكي اثنيناتهم صح، فيكم تاخدوا اللي بدكم اياه لأنه by action reaction هن equal in magnitude opposite in sense same direction opposite sense. So إذا باخد أو A أو B it's ما بيأثر. So let's say أخذت A. اوكي let's say أخذت A أنا صار معي صرت أعرف الانيشال والفاينل velocities تبع A. اوكي لأنه عندي VA1X بعرفها. اوكي VA1Y بعرفها كمان. I want to deduce معي كمان VA2X و VA2Y. I want to deduce الامبulse كيف حيكون. اوكي طيب so الامبulse can be calculated. يعني هلا انا فيني من الفيجر اعمل estimation كيف حيكون الامبulse. يعني بما انه الواي الامبulse IY اكيد حيكون upward لانه الفيلوسيتي كانت negative in Y صارت positive. يعني اكيد الاي واي like this. وبالنسبه للاي اكس فيني اعرف حسب التشينج ان velocity يعني مين اكبر VA1X او VA2X. من الكالكوليشن تبعي بتكون بينت معي الفاليو ففيني دغري حطها ساعتها على هالاساس او من الساين يعني بعمل assumption ومن الكالكوليشن بعرف. اوكي let's say مثلا حطيناها for example in this way مثلا. اوكي اذا حطيت هول الاي اكس والاي واي to get them بدي استعمل الامبulse and momentum on A in X and Y direction. فاول equation بتكون MA times VAX at state 1. هلا انا عامل assumption انه IX to the left يعني بحط minus IX equals to MA times VAX at state 2. بما انه معي VAX1 و VAX2 I can calculate the impulse along X. I will repeat the same procedure along Y. يعني MA times VAY at state 1 plus IY equals to MA times VAY at state 2. صار فيني اجيب بما انه بعرف VAY1 وبعرف VAY2 صار فيني اجيب الامبulse along Y. once صار معي الامبulse vector ساعتها I can deduce the direction of الامبulse vector لانه معي الكومبوننت تبعه. if I want to calculate alpha اذا بدكم I can just say that tangent alpha is equal to the absolute value of IY over IX. And I can then say that this will be the corresponding direction of the line of impact. لأنه impulse will be along the line of impact. Okay? Any question on this?
دكتور
نعم.
بس مش لازم تكون بلس اي اكس اللي اخدناها على الشمال.
ما أنا آخذ البوزيتيف إكس هيك. إذا أنت آخذ الإكس بوزيتيف هيك. أوكي؟ فأنت إذا أنت you assumed IX للشمال يعني هي الالجبرايك فاليو لها نيجاتيف صح؟ يعني انت اذا حطيت على الفيجر فيكتور هيك بيكون الاكس كومبوننت تبعه بوزيتيف او نيجاتيف اذا انت الاكس كومبوننت بوزيتيف هيك.
اوكي ثانك يو. بس هي مش ال VAX نفس الاكس ولا مثل الاي اكس؟
انت فيك تنقل الاكس اكسس مثل ما بدك، اتفقنا؟ يعني انت اذا هن حاطين لك الاكس اكسس بالفيجر فانت التزم فيه، هن حاطين لك الاكس اكسس بوزيتيف هيك، فاذا انت من الفيجر VA1X is negative، يعني انت when you replace VAX1 حتحط negative value لانه هي لورا، ونفس الشيء بالنسبه ل VAX2 كمان negative. اوكي، هلا الاي اكس فيك تعمل لها assumption، انا ما بعرف من قبل، هلا انت لانه عامل calculation حيبين معك اذا VA1X زادت in absolute value او لا. اذا VA2X in absolute value اكبر من VA1X يعني اجباري الامبولس in X to the left. اوكي، اذا لا بيكون to the right، يعني انت فيك تعرف من قبل لانه عامل calculation لل VA1X و VA2X، ففيك دغري على هالاساس لانه معك الفاليوز تنتبه كيف حتكون اي اكس. اذا ما انتبهت بتعمل بتحطها كيف ما كان على الفيجر وبتشوف اذا طلع لك ريزلت بوزيتيف يعني اي اكس تو ذا رايت، واذا طلع لك اي اكس نيجاتيف يعني اي اكس تو ذا ليفت. اوكي، بس
اوكي
انت
ثانك
هون بالكونفنشن تبعك يعني على طول بدك تعمل assumption، اذا طلعت لك الاسامبشن مضبوطه بده يطلع ريزلت بوزيتيف، واذا طلعت الاسامبشن غلط بيكون الريزلت تبعك نيجاتيف يعني هي بالعكس. بس اذا في شيء مش واضح برجع بعيد.
نو دكتور، انا ضاعت لانه ال VAX ما انتبهتش انه هي نيجاتيف.
اوكي، خليني فرجيك نيوميريكلي هون شو بيصير مثلا تتشوف كيف. مثلا انت جبت انه VA2 0.766. اوكي، صار فيك تجيب ال VA2X قد ايه الفاليو تبعها. VAX at state 2 هي VA2 هي نيجاتيف، هي minus 0.766 times cosine times sin بيتا. اوكي، جرب اعمل لها calculation شوف قد ايه بتطلع. you should compare it with VAX1. يعني حاعطيك example، هيدي اثنيناتهم نيجاتيف VAX1 و VAX2 صح؟ بس اذا in absolute value VAX2 عم بتزيد يعني عم بتصير more negative، اجباري الاي اكس تكون هيك صح؟ لانه الامبولس اللي بينعطى له هو بياثر على الفيلوسيتي تبعها. اذا انت اعطيتها امبولس تو ذا ليفت فهي حتصير مور نيجاتيف، يعني حتصير في اي اكس ان ابسوليوت فاليو اكبر، بينما اذا الامبولس along x positive يعني اذا البي عم بتشد فيها towards the right ساعتها بتخف النيجاتيف فاليو تبعها، يعني بتصير less negative.
اوكي دكتور ثانك يو.
هلا اذا انت قررت ما تتطلع بالفاليوز ما تعمل كالكوليشن وتقول بدي اعمل حيلا اسامبشن كمان فيك بتروح على الفيجر بتقول بدي اعمل حيلا اسامبشن او باخذها تو ذا رايت او باخذها تو ذا ليفت. مهم يو شود بس تاخذ اسامبشن تمشي عليها. يعني اذا انت رسمتها على الفيجر تو ذا ليفت وقتها بما انه البوزيتيف دايركشن ان اكس تو ذا رايت بس تيجي تكتب الامبولس بتحط ماينس اي اكس لانه انت اوريدي نقيتها بالعكس. اوكي، ساعتها اذا طلعت لك بالريزلت اي اكس بوزيتيف يعني انت مزبوط اخذها مثل ما هي، اذا طلعت لك نيجاتيف يعني هي بالعكس. اوكي، بينما اذا انت على الفيجر حطيت اي اكس من الاول تو ذا رايت وقلت شوف شو بيطلع لي بالكالكوليشن، ساعتها اذا اي اكس بوزيتيف يعني هي مزبوط هيك، واذا اي اكس نيجاتيف طلعت لك بتكون ساعتها بالعكس. اوكي
اوكي ثانك يو.
وساعتها بتحطها بالايكويشن اذا انت اخذها هيك بتحطها بلس اي اكس بالايكويشن لانه انت منقيها بسيم البوزيتيف دايركشن اللي هي تبع اكس اللي هي towards the right. اوكي any question any other question on this? اوكي we are done for today. حنصير كل Monday نعمل extra session. اوكي يعني بنعمل بكره ومن هلا لنخلص الصفوف بنعمل كل Monday at 12 11 او 12 كنا عم نعملها Monday.
يلا I'm checking دقيقة بس.
اوكي anyway any time يعني التايم اللي كنا عم نعمل عليه Monday حنصير نكمل كل Monday نعمل extra session اوكي